Hello. Today I'm going to be talking about a model builder model that I created in ArcMap for a project called the Solar Wind Village project. So the model you see right now is my final model that I came out with for this analysis. To get to this point though, I had to first come up with my criteria. The criteria selected for this solar wind village to best promote green developments within a community. So you had to have a southerly aspect from 135 degrees to 225 degrees. The slopes had to be less than 20 degrees. Land use had to be suitable. For this case, the land use I chose was multifamily residential, high density residential, medium density residential, low density residential, and urban public institutional. And lastly, very low density residential. Some of the other constraints was the site has to be within 400 yards of an existing road, and wind speeds at 30 meters greater than 5 meters a second are highly suitable. Wind speeds greater than 4 meters a second are still suitable, and wind speeds less than 4 meters a second have limited suitability. Later on I'll show you my outcome on a map that I created with an ArcMap as well that depicts which areas in the city are most suitable from a categories 1 through 5. And when I say categories 1 through 5, as I'll explain in a little bit, that means if one of these matched with one of these and one of these, in this case just those three matched, it would be 3 out of the 5. Whereas all 5 would be 5 out of 5. So I'll show you this later on in better detail. To start, missing from this image right here is the prior models that I created. They were smaller to help me better understand ModelBuilder. As this was one of the first few times that I've actually worked with it, I wanted to practice. So creating all these original inputs was smaller models. For example, in the wind extract, I did extract by mask because it used to be at 200 meters, and then I resampled it down to 38 meters. The reason why I chose 38 is while I was running this analysis, originally I was a bit confused. So I accidentally set it to 38 and then realized that instead of going back and rerunning everything and just adding too much clutter within my geodatabase, I went back and I reset everything else within here to 38 meters to make it easier on myself. As while I was going through this process, I've realized a couple different times when I was using the raster calculator, which is one of the tools within ArcMap, that I was having a difficult time getting the model to run with raster calculator. So I had lots of random output names in my geodatabase, so I had to go back, clean up my geodatabase, and that is the reason why I kept it at 38 meters. As I already talked about with the land use categories that I used, I had to use another tool called poly to raster, or polygon to raster. I used this a couple times within my model, here and here, as this changes a polygon data set to a raster data set. In order to use the raster calculator, of course, you have to have everything in a raster form. So all the outputs you see outside of the 5 raster calculators are either a 0 or a 1. If the output is 0, it doesn't fit the constraints that were set originally on this project. Whereas if it fits the 1, it falls under this. This relates back to the end-up variable, where if you multiply them all together, you get which areas are suitable versus which areas are not suitable. Alright. I will now show you my final map. So this is my analysis map right here. This is the city of Chicopee within Massachusetts, and the focus area is actually the most suitable area, including wind speeds. One of the drawbacks of showing a site suitability value when you multiply them is this whole green area in this part of the city can be very good to do green development, but it's not telling you specifically which categories that it's fulfilling. And sometimes, that's the most important part, is if there's no wind speeds in here, this whole green development will not work. So as you see over here, this was the most favorable area with wind. And when focused upon, you find out that this is a very dense, already built out Air Force base. So unless this were to get closed down, demolished, and completely redone, which almost defeats the purpose of greening a community, it just is not feasible. And you see this a lot throughout New England, as New England is a very built out area, unless you're in like the rural hill towns within Massachusetts and such. So therefore, it's important to note that even if you have a suitable site, there could already be land use on it. In my case, this area right here in the orange is a very suitable area, as it's a runway. So wind speeds are going to track a lot better there, as it's wide open. But there's no roads within 400 meters of the runway, so that's why that area is in orange. So this explains the suitability values. So as you can see, there is a dark green in there, which is a 5, which is all 5, as well as mostly 3s and 4s as well. So this is why a suitability analysis is important, because you can then see what's your outcomes are. In my case, I saw this one area and I decided to investigate it more. And while investigating it more, I discovered that, of course, it was an airport, and a project like this just would not be fit on a military installation that's already predominantly built out. So finally, I'm going to go back to my document, and this was I did, and I hope you enjoyed this video explaining my model. And I will also link this document to this YouTube, so if you have any ideas or feedback that you want to give me, I would really appreciate it. Thank you for